Okay, so in this chemical equation, we have ethane reacting with oxygen and producing carbon dioxide and water. This is one of those that you can balance it temporarily at least by using fractions in the coefficients. I like to use decimals instead, but it's your choice at the end of the day. I feel that with the decimals, it's a little bit easier though for students. So one of the first things that we need to do is find out how many atoms we have for each of the elements. So we have 2 carbon atoms, we have 6 hydrogen atoms, and we have 2 oxygen atoms. And then on the product side, we have 1 carbon atom. And I know there is only 1 carbon atom because if it doesn't have no number, then at that point there's a 1 understood there. And then there are 2 hydrogen atoms. And then there are 2 plus 1 means that we have 3 oxygen atoms. Now, at this point, we need to identify the loner, also known as the pure element, is not part of a compound. So the only one that is not part of a compound would be oxygen. So I'm going to write it in here. Next, we need to identify the 1:1 ratio, also known as the pair element. And that is the element that appears one time on the reactant side and one time on the product side. And it doesn't matter if the subscripts are different. So carbon, it appears one time on the reactant side and one time on the product side. So I'm going to put a little check mark. Hydrogen, it appears one time in the reactant side and one time in the product side. So I'm also going to put a check mark. And oxygen, it appears one time in the reactant side, but it appears 2 times in the product side. So I will not put a check mark. Next, we're going to start with the largest 1:1 ratio, also known as the pair element. And this is the element that has the largest subscript. So based on the ones that we put the check mark on, the one with the largest subscript is going to be the hydrogen in the reactant side. So I know I have 6 atoms of hydrogen, and over here we have 2 atoms of hydrogen. So what I can do, I can put a 1. And when I put a 1, I'm saying 1 times 6 gives me 6. And over here, I need to try to make this 2 into a 6. So the way I can do that is by putting a 3. I'm sorry, putting a 3 over here. 3 times 2 gives me 6. And we are done with our hydrogens, at least temporarily. And this 1 is going to lock the whole thing, the whole compound. So 1 times 2 is 2. So therefore, I need to have 2 carbons over here on the right side. And by the way, I'm done with my carbon, so I can mark that out. So I need to have 2 carbon atoms on the right side. So I'm going to put a 2 in the coefficient. So now the carbons are balanced out, the hydrogens are balanced out, and I have only the loners left. And that's what you want to end with the loners. If you have that option, try to end with the loners. So now we need to find out how many oxygen atoms we now have in the reactant side. So we have 2 times 2 gives me 4. And then plus 3 that we have over here. So we have a total of 7 oxygen atoms so far. So instead of me messing with the coefficients, since the carbons and the hydrogens are balanced from both sides, what I can do, I can use decimals to find out how to balance this chemical equation. So I can say 2 times what number gives me 7. And by the way, this 7, I'm getting it from over here. I'm just writing it over here temporarily. So 2 times 3.5 gives me 7. So I'm temporarily going to put 3.5 in here. Of course, that cannot be my final number for the coefficient here because you cannot have decimal numbers, but we can have it temporarily. And then we're going to multiply everything by 2 so that way we can have whole numbers in the coefficients. But before I do that, I'm going to erase all this so that way we can have everything organized. So I'm going to multiply everything by 2. That's just the standard rule to start out by doing that. And then this 2 is going to distribute to all of the coefficients. So you're going to say 2 times 1 is 2. 2 times 3.5 is 7. And then 2 times 2 equals 4. And then 2 times 3 is 6. So now let's see if we have everything balanced. But before that, let's get a little bit organized here with our numbers. So this turned out to be a 2 now. And I can erase this because I'm done with that. It's a little bit hard to erase sometimes because I don't want to erase the other stuff. So now let's see if everything balances out. So 2 times 2 gives me a total of 4 carbon atoms. And then I have 4 carbon atoms over here as well. And then for my hydrogens, I have 2 times 6 gives me 12 hydrogen atoms. And then 6 times 2 gives me 12 hydrogen atoms. So far everything is balancing out perfectly fine. And then for my oxygens, I have 7 times 2 gives me 14. And then over here on the reactant side, I have 4 times 2 is 8. And then plus 6 gives me a total of 14. So at this point, everything is balanced out. Our final coefficients are going to be 2, 7, 4, and 6.